the inexpensive fan roundup. Here we are in Computer Tech and More. Let's take a look at some inexpensive fans. First up, we have the Noctua NF-P12 Redux. Then we have the Arctic F12. And last, but certainly not least, we have the Arctic P12. Let's jump right into the graphs, and then we're going to deep dive onto each of the fans' boxes and features and what kind of comes with each of the fans, and take a closer look at the fans. If you haven't already subscribed to my channel, please hit that subscribe button. It'll really help me grow my channel. I also have a Patreon page, and really thank to all my supporters who help pay for and fund this channel so that I can continue doing testing and can hopefully upgrade my test equipment to get more accurate data. Before we get into the graphs, I want to apologize. I've got a little bit of a cold, so if you hear me sniffling, that's why. Anyways, this is the data that I collected for the NF-P12 Redux. If you want to use my data, please give me credit because I'm the one that collected it. Anyways, let's move to the next fan. And the next fan in this roundup is the Arctic F12. Here's the data. I'll leave it up for a couple seconds. You can pause it if you want to use it. And the last one is the Arctic P12. All right, let's move into the graphs. This first graph here is for the Arctic F12, and it's the distance from the fan at versus airspeed. So airspeed is the y-axis, vertical, and the distance from the fan is the horizontal axis, the x. And I selected RPMs, which are represented by the different color lines based on the PWM signal. And in a perfect world, you would see it as a perfectly flat line, horizontal. That would mean that there's no airspeed lost across the distance from the fan. But we don't live in the ideal perfect world, so we do see losses. So we want to see it as linear as possible and as flat as possible. Overall, the F12 looks pretty good. Around 1 meter per second lost at its maximum RPM, and about 1 meter per second also at its minimum RPM. So that appears to be its loss. Okay, the next one is the Arctic P12. So the naming is going to get a little confusing because Noctua and Arctic share very similar naming schemes. But anyways, let's continue. The P12 looks like it does fairly well. At its maximum RPM, starting at 2.5 approximately meters per second, and it drops to about 1.5, so around that 1 meter per second still. But at its minimum RPM, basically loses nothing, but also doesn't move very much air. All right, let's go to the last one. And the last fan that we're going to look at distance from the fan on these type of graphs is for the Noctua NF-P12 Redux. And we can see here that at minimum RPMs, it does very bad. And at its higher RPMs, it only pushes 1.8 meters per second of air, and it drops down to 0.4. So it basically just has a very dispersed airflow. So it's not very good at being a case fan. Let's go ahead and look at the other graphs. All right, this first graph here is RPM on the X horizontal axis versus airspeed on the vertical axis through an air cooler. So in this graph, the way it's laid out is the better fans are going to be higher than my average fan here at this blue line. So what this tells us is how efficient the fan is at pushing air at a given RPM. It's not its noise performance, it's basically rotational versus airflow performance. And all the fans actually do kind of well. The Redux here in this green dots is the best. The P12 does pretty well. The F12 actually does surprisingly well considering that it's an airflow fan. Actually at lower RPMs it looks like it actually does better than the P12, but the P12 catches up as the RPMs increase. Moving right along, now we have RPM versus CFM. Again, this is an efficiency type one for how good the fan is by itself, not noise-wise, just how much air it can push at a given RPM. And my average line is the blue, and we can see that the P12 is below. Not by a lot, but a little bit below what my composite average fan, which is all the fans that I've tested to this point's average. The Noctua P12 Redux is a little bit above my composite average fan, and the F12 is the best in this roundup. Now for noise performance. My horizontal axis is noise. My vertical axis is CFM, so that's cubic feet per minute. So I have changed units from meters per second to cubic feet per minute. And yes, I did apply all the conversions. I have it actually on my Excel sheet to do the math. Anyways, my composite average fan, this includes 140 and 120s as kind of an average. You can see that the P12 and the F12 are just off the average fan's performance, while the P12 Redux from Noctua is over the average. So this means that the two less expensive Arctics are just not quite as good noise-wise at a given RPM or CFM compared to, well, the Noctua in this case. Moving right along to the next one, this is noise versus a given RPM. So this is how much noise it does at basically a spin velocity. My average again is that blue line, the darker blue, this one, while the light blue is the F12, and you can see that it's below the average line. The P12 is also below the average line, while the Noctua P12 Redux is better overall. So again, kind of reiterating the past points that we've made, where the Noctua is better at noise for any given RPM, CFM, that sort of thing. But if you're looking at purely how efficient the fan is at pushing air, any of them are pretty close. This next graph is noise normalized distance from the fan versus airspeed. So similar to the first graphs, except I've selected the noise normalized value from my readings at 40 decibels and determined what the airspeed is across the distance from the fan, and the vertical axis, the y-axis, is the air velocity. So here we can see that the F12 is overall doing the best. The average fan here is this darker greenish blue, I want to say. Well, that's what I'm calling it. Anyways, and the P12 is the sort of more regular blue, while the NF-P12 Redux is the green line. So clearly we can just see that the Redux is not very good at airflow, period, at all. Surprisingly, the pressure optimized P12 does pretty well, especially as you get farther from the fan. It catches up and then does a little bit better than the F12. The F12 does much better early on. Let's go ahead and see what it looks like at 100% PWM. Same sort of graph, just at 100% fan rotational speed. And again, we see that the Noctua P12 Redux is overall doing the worst. However, if you're looking at my labels on the graph, so it has the RPM, the noise for each one, as the last two, you can see that they all have similar, actually the F12 is a little bit less, but pretty close RPMs. But the Noctua is significantly quieter. So you have to take it with a grain of salt, everything that we're looking at. But overall, I would say I wouldn't use it as a case fan, period. It just doesn't, its air is very random unless you're looking at a small form factor where the goal is to just push air past a whole lot of obstacles. The P12 does particularly well here, pretty much matching the F12 early on, and then it's much better as you get farther from the fan, which is surprising because it's pressure optimized, while the F12 is supposed to be airflow optimized. And the F12 and P12 are both better than my composite average fan. All right, let's go on to the groupings where I have all the fans I've tested so far. So overall, how do the fans rank? So this gray line represents my composite average fan, right there at the top. And the F12, the Arctic F12, not to be confused with the Noctua, is down here towards the bottom. It's pretty close to the average fan, 0.1 meter per second. But it is not as good as the average fan. The P12 is right up here. It does a little bit better. It's right on track with the average fan, and similar to the actually does better than the 140 millimeter Silent Wings Pro. So again, this is noise normalized. I don't remember if I said that, but it is off the pace of the A12X25 through a cooler, noise normalized. And last but not least, the NF-P12 Redux is right up here towards the top at approximately 1 meter per second. So there is some round off, which is why you see it below. I'm only listing it to the first decimal place because that is the true accuracy of my anemometer. But I'm using basically partial fractions or a interpolation to derive what where the performance of the fan should be based on 2 points on each side. So the P12 ranks right up there at the top in noise normalized testing, right behind like the T30, the Silent Wings 4 Pro, and the Noctua A14, which is a 140 millimeter fan. So it does particularly well in this application. So if you're looking for a new fan for either a radiator or an air cooler, that might be the one to get, especially if you're looking at near silent operation. All right, let's look at it at 100% PWM. At that 100% PWM, here the maximum RPMs are really going to show through, and right up at the top we see that the T30, the NF-F12 industrial right there, and the industrial A14, but those are 3000 RPM fans. Let's go down to the more regular type fans. So right towards the top of the pack of regular fans, we have the NF-P12 Redux with a noise level of 52 decibels. So it does pretty well. It's a little bit off of the higher performers, but at pretty good noise levels. The Arctic P12, is right behind it at approximately the same air velocity, but it is significantly noisier. It's more than 10 decibels noisier at this RPM. So if you can put up with the noise, it is a great cheaper choice because it is $5 cheaper, which means it's 50%, a third less money. But it would be an excellent choice. And then we have the Noctua A12X25, more or less within error, about the same performance, and significantly quieter. Well, not significantly. It's a little bit quieter than the P12 Redux. And then as we're looking for the F12, it's down here. It's towards the bottom. I wouldn't recommend it for a CPU cooler, but this is how they compare to other fans. Next up, I call this one of my kicks and giggles graphs because it's really hard to read, especially if you don't have an Excel chart in front of you to be able to click on the various lines. But this is how the different fans compare to each other. Up here at the top, this graph represents noise normalized distance from the fan versus airspeed. Airspeed is the vertical axis, distance from the fan is horizontal. All right, so as we're looking at the graph, the NF-P12 Redux is basically right here at the bottom, not very good at pushing air through a case, although it does particularly well at the 6 inch mark, which sort of is my representation of a small form factor case. This blue line that I just highlighted is the P12 Arctic fan. So it actually is pretty good overall when compared to other fans. And last, but certainly not least, is the F12, which I just lost my highlight. There it is. And it also does pretty well when compared to other fans I've tested. And this is not all the fans. I deleted some just for simplicity's sake and just sort of left sections up there. But the very best at moving air across a case is like the Silent Wings 4 Pro 140 and the Noctua A14 IPC and the fan from the Torrent PC case with 180 millimeter. And how do they compare at 100% PWM signal? Well, up here at the top, we can see The very best is the 3000 RPM NF-A14. How about the fans that we're looking at specifically here? Here's the NF-P12, basically at the bottom. The P12 is the one I just highlighted right there in that blue line. And the F12 is the one that is now highlighted. They are basically middle of the pack. And if you're looking at the key over here on the side, you can see RPMs. So you have the fan name, RPM, and how much noise it's generating. So the two Arctic fans are, well, particularly the P12, is on the noisy side compared to other fans at its given airflow. But if you can put up with it, it is a middle of the pack performer at case airflow situations. Moving right along, keeping in that same thing of case airflow type situations, this is noise normalized at airspeed at the 9-inch distance, which I figure is a pretty good middle ground between a small case and a big case, that sort of thing. If you look at my methodology piece, I do have a full explanation as to why I chose each of the distances that I did. But anyways, looking specifically at this, we can see the Arctic F12 is right here at 1 meter per second. The P12 is right there at a slightly better 1 meter per second. So again, you can't see the round off, but they're functionally equivalent. And right here at the bottom in the orange with the red lettering is the NF-P12 Redux. It just does not do very well once you're farther away from the fan itself, so it disperses the air pretty widely. So it's very impressive that the F12 and P12 from Arctic actually do a pretty good job focusing the air, especially at their given price point. They rank pretty well in the middle of the pack, and the NF-A12 X25 is sitting right here, actually a little bit below them. Next, we have the same thing, the 9-inch distance in the case airflow test, but this one is at 100% PWM signal. So right off the bat, near the bottom is the NF-P12 Redux, right here in the red, at 52 decibels, and I didn't even list its meter per second airspeed because it's at the bottom. I wouldn't recommend it at all, period, end of story, as a case fan, unless you're putting into a very tight small form factor case where you're literally pushing past obstacles. So past that, the Arctic F12 is up here at 1.9 meters per second, and the Arctic P12 is a little bit better at 2.2 meters per second. So it does have a slightly higher RPM than the F12, which I think is part of it, but I also think that that blade design might be particularly efficient at just pushing the air, at getting it back, and also doing a pretty good job at doing a focused airflow. And the fans are pretty well in the middle of the pack, with my average fan indicating a 1.8 meter per second. So they are on track and actually a little bit above my composite average fan as compared to all other fans I've tested. All right, another kicks and giggles graph. This one is at the 6-inch distance, and it's airspeed on the vertical versus noise on the horizontal. And better fans are going to be more airspeed this way, vertical, for the same amount of noise. So the worst fans are going to be down here, the best fans up here. You want less noise, more airspeed. So over there, the very best is the, I don't even know which one this is, Silent Wings 4 Pro 120 millimeter size fan. The Arctic P12 is over here. It actually ranks sort of on the worse side of things. And the F12 is this line. It actually ranks pretty well. And the Noctua NF-P12 Redux is this purple line I just highlighted. It's basically in the middle. And again, this is the 6-inch mark, which is more representative of a small form factor case, pushing air that distance as opposed to a bigger case. But yeah, the P12 from Arctic is just not very noise efficient, basically. Moving on to noise normalized CFM. So here you need to look at the top parts over the gray, this first gray line separately, and the bottom gray line as a different group, because I have a different testing apparatus for 140 and 120 millimeter fans, so they're not directly related, but I put them all on the same graph. I may split it out as I collect more data. So again, this is noise normalized. Right here towards the bottom, we have the Arctic P12 spinning at 711 RPM, pushing out 28.1 CFM. And that is a good bit behind the average 120 millimeter fan. And that's a composite 120 millimeter fan. It's a average of every other 120 millimeter fan that I've tested thus far. So this is where it's interesting why I developed and did that case test as opposed to just raw CFM numbers, because the Arctic P12 did pretty well in that case, but the moment we take a look at CFM, it's all of a sudden towards the bottom of the pack. The Arctic F12 does quite a bit better at this noise normalized CFM. It pushes 32.9 cubic feet per minute of air. It's just a little bit behind the average fan, and it's spinning at a little bit slower speed than the P12. And as for the Noctua NF-P12 Redux, it does a little bit better. It's spinning at 889 RPM and is pushing 38.7 cubic feet per minute of air. And it's doing quite a little bit better than my composite average fan, but not quite as good as like the likes of the NF-A12X25 or the new Silent Wings 4 Pro. So this gives you an idea of how they relate in a pure CFM, cubic feet per minute, air movement, basically. I apologize for this graph. It was very hard to make the data readable, but here we are. This is the best I could think of at this moment. I'll try thinking about it in the future, but this is 100% CFM. The data reads as the model number. For some of them, I labeled as like 3000, so that's just dictating which model it is. The RPM is the next, and then its noise level is the last indicator. And again, same as the last one, we have 140s at the top, 120s at the bottom, composites of 140 and 120s on either side as those gray bars. And let's go into detail as for how each of the fans compare. So right here next to my mouse is the Noctua A12X25, just as a key reference. It ranks a little bit above my composite average fan here in the CFM. The Arctic P12 at this green line, it pushed 63.6 cubic feet per minute of air, so it's a bit behind my composite average fan. And it's pretty noisy at 65 decibels. It's among the noisiest fans there. Here, matter of fact, it's almost as noisy as the 3000 RPM industrial NF-F12 IPC model. The Arctic F12, on the other hand, is only 56 decibels, so it's significantly quieter. So what I think is actually going on with the Arctic P12 is it's got just some bearing noise, or maybe that like tip wind sound is going on, making it particularly noisy. But again, this is why we have this CFM, and in addition to that case test, because they just give different portrayals of these fans and give you a wider perspective of them. Arctic F12 case test. Arctic P12 at 100%. NF-P12 Redux. And another kicks and giggles graph because it's really hard to read, but it has a lot of extra data on it in a graph form. So the horizontal axis here is decibels. The vertical axis is CFM. So a better fan is going to have higher CFM at a lower decibel. So you can see some of these fans just get rip-roaring, really high CFM, but also produce a lot of noise, and other ones just do better than the others. So like, well, let's focus on the fans for this data set. There's the Silent for Pro 120. All right, so the one that's highlighted currently is the NF-P12 Redux. You can see that it actually in CFM versus decibels is on the better side, except for it starts to trail off at its higher RPMs. The orange line represents the P12, and you can see that it's just not particularly efficient at CFM versus decibels. And last, but certainly not least, is the F12, and you can see that it's on the trailing side. It's a little bit behind several of the other fans, but it's adequate. It's good enough. And when you're over here at these lower decibel readings and low CFMs, it's going to have a lower RPM over here as well, so it matters a lot less. You start to see a lot of differentiation at this 40 decibel mark with what I would say adequate. This is where you really want to be targeting your CFM airspeed kind of indicators. Now that we finished going over the graphs, let's take a look at what these fans come with. So the Noctua NF-P12 Redux is a 1,700 RPM fan. It's got a standard 25mm thickness, 4-pin SSO bearing. It's their older bearing technology. Airflow is rated at 120.2 meters cubed per hour. Acoustic noise rated at 25.1 dB. Static pressure at 2.83, which is very good. And 1.08 watts with a 0.09 amps. And they make a couple different versions of this, as well as a lower noise version that's 1,300 RPM, I believe. But this is one I chose. Inside the box, you get plastic and some screws. Very basic. So on to taking a quick look at the fan. So it does have a bit of an angle going into the middle. Its blade design is somewhat similar to the NF-F12, except the P12 has a little bit more of a angled front to it, but both of them feature wide, more or less flat blades. You're going to notice right away that the fancy versions of the Noctuas have this stepped inlet and this dimpled interior. The Redux does not. It's just smooth, but its clearance to the wall is visually looks a little bit tighter than the F12 anyways. And its back is a very basic, although it is angled, and just the blades have this little cutout on it, which is supposed to help with like vortices and that kind of thing. Without doing like a full CFM analysis, CFD analysis, I wouldn't be able to tell you exactly what it's doing, but the blades are basically smooth and pretty basic overall, just a standard PC fan. And as we saw from the data, this fan is well optimized for radiators and not so much being a case fan, which makes sense as I just talked about the blade design just now. Next up, let's do the Arctic P12. So this has a 10-year warranty. Oh, I forgot to mention the Noctua has a 6-year warranty, I believe. Yes. So with Arctic, you get a little bit more warranty. The box is visually not as nice, and inside you get some screws. Information on the box, pretty sparse. It does have its RPM range on the bottom, 200 to 1800, so a pretty similar RPM range. Airflow is right at 56.3 CFM or 95.7. What was it over here? 120.2 meters cubed per hour. So I was reading both of them in meters cubed per hour. In CFM, which is what I'm calculating it, it's 56.3. 2.2 millimeters of H2O. What's it over here? 2.8. So actually similar-ish. The Noctua should edge it out though. Fluid dynamic bearing. That's a pretty good bearing type. Noise level is 0.3 zone. I'm sorry, I'm not familiar with that one. And current is 0.08 amps at 12 volts. 4-pin connector. Standard thickness. All right. And here is the fan. So this fan is around $9, I believe. So the blade shape is very reminiscent of the Noctua NF-A12X25, except the blades are a lot thicker with more space between them. So it's definitely more geared towards being a pressure fan, but as we saw from the data, it actually does a pretty good job at being a case fan, which I can only attribute to the blade design, that it's somehow got a pretty good hybrid nature, because the frame itself, I don't know if it'll show up on camera very well, but these back struts are actually angled in a shape so that air flows over them pretty smoothly, but the frame itself doesn't feature any extra features to help direct airflow, which means it's all up to the blades themselves. And looking pretty closely at the blades, there's sort of a cup shape with a little bit of lip at the very tip where it curls up, which should help direct the airflow back. These fans do not have any vibration dampers or anything like that. It's just a fan, and it's $9. So what do you expect? It does a very good job, and it looks pretty good, in my opinion at least. All right, let's go to the next one. And last but certainly not least, in the fans we took a look at is the Arctic F12, and this is the case fan as opposed to a pressure optimized fan. So, you know, they have the information on the front. And let's see. Oh, this box actually looks quite a lot nicer than the other one. So it talks about how it directs the airflow through it, has some verbiage on it, but let's get into it. So 53 CFM or 90.1 meters cubed per hour. Actually, that seems very similar. Airflow, yeah. The airflow is very similar to the other one. I'm sorry, the P12. The bearing is a fluid dynamic bearing, 0.3 zone, 12 amps, 12 volts, I'm sorry, 0.12 amps, has its dimensions and its weight. All right, let's get into the fan. So the blade design is, I don't know, looks like that. Kind of like, moderately similar to like the Noctua NF-A12, A and B. So those are their airflow fans, where to get better airflow, instead of the plates being, you know, this is the fan flat, you have them tilted out, and that actually helps suck air through, but it kills the pressure optimization. So it basically will do a terrible job at anything other than airflow through a case, and actually doesn't do a very good job with radiators or any sort of obstruction. And as we saw from the graphs, this one actually does an okay job. with radiators, but it really is more of a case fan. Its struts in there are a little bit of an angle to them, not as much as I would like to see, I guess, but still pretty good. The wire management here, it's got a very thin wire, but it fits very nicely, as opposed to like the Noctua, where it's much, much wider. But Noctuas also have, well, I guess that one for the wires is pretty steep. So that actually, that tight or very small obstruction, actually you see it on the P12 too, means that more air is able to push past that more easily. But it does have a smaller rotor hub, which means you got more surface area for the blade. But it also means that there may be less torque inside the motor itself to handle those obstructions, or even, what am I saying? Like change speeds as readily. Blade distance from the edges is pretty substantial, which again, in an airflow optimized case is fine, but in reality, you want the blades as close to the edges as possible. Now, they could leave that extra spacing because the lower quality materials and lower quality material fan blades will stretch over time, while higher quality ones, like used in the A12X25 Noctua, are designed not to stretch, so they can get that much closer gap. Because eventually, on a less expensive fan, don't know how true it is on this, but the blade would start hitting the frame and you get a terrible scratching sound. Now that we've looked at all the graphs comparing all the fans, we've gone in detail looking at the fan specifically and kind of open boxing. This leaves us with the value proposition. So I looked up the pricing of each of the fans, and took their performance for each of the graphs into consideration. And here, a longer bar indicates that it's a better value. So this first graph is the 6-inch distance, performance per dollar, noise normalized. This line that I just highlighted is the F12. It does really well. It is a great value for its performance as a case fan. Next, we have the P12. At noise normalized values, it is also a great value. They are among the best performance per dollar, noise normalized of all the fans that we've looked at. This one I can't find anymore. If you can find the CFV12HP from Cougar, it is also a good choice. The P12 Redux at the 6-inch mark is also a good value. And the NF-P12 Redux is also a good value at this 6-inch distance, noise normalized. If we take maximum performance of the fan into consideration, so this is 100% PWM, the P12 and F12 are still very high performers. They have still a very good cost or performance per dollar at that level there. And other fans kind of rank better at this that were worse before because they just have a higher RPM, so it kind of arbitrarily boosts the performance. Let's see, right here is the NF-P12 Redux. It's sort of, I'd call that middle of the pack. Okay, let's take a look at the next set. All right, same sort of thing. This is the 9-inch distance performance per dollar, noise normalized again. And the top performers here are, well, still the P12 and the F12. Both of them perform very well noise normalized. Then we have the NF-P14S, I believe that's a Redux as well. The fan I mentioned before, the rest are all kind of middle of the pack. The T30 does really bad. Okay, let's take a look at it at 100% PWM. So at that 9-inch distance, once we take into account the maximum amount of air the fan can push, the P12 and F12 still rank very well. They are at the top of the charts because they're so inexpensive to some of the other fans, which I will admit most of the fans I've looked at so far are $30. So if you really need to fill out a case for pushing air through it, you really can't beat them for their value. The 3000 RPM Noctua NF-A14 jumps up a lot here, but it's still not as good value as the other two, although even though it can push more air. All right, let's jump on to some of the other tests and see the value propositions there. For the value proposition of performance through a CPU cooler, noise normalized, we can see the P14 is really the top of the charts. It is the best. The P12 Redux, not quite as good at that value proposition, but still very good at the very top of the charts. The F12, I just wouldn't recommend it, even though it does pretty well at this graph. And if you have a larger air cooler, the P14S does very well, does very good as well. Now at 100% PWM. At that 100% PWM signal, the very best is, drumroll please, the P12 from Arctic. It just blows everybody else out of the water in that performance per dollar, ignoring noise altogether, running at flat out full speed. Amazingly, the F12 is towards the top of the charts, and that's mainly due to its low cost. Again, I would not recommend it for this purpose. The P12 Redux is pretty close to the top of the charts. If you're really short on money, the P12 Arctic is the one to go. If you've got a little bit more to spend and want better noise performance, I would go with the P12 Redux from Noctua. And last, but certainly not least, for the graphs of value proposition, we have the CFM. So this is the pure cubic feet per minute values for the fans. And at the top of these graphs, noise normalized, we can see that the Noctua NF-P14S Redux is the best value proposition in CFM. So kind of interesting how it flipped from case airflow to CFM. So CFM I would look at as basically all-rounder, while through the cooler and the case are more specific for use cases. Here, the F12 overtakes the P12, but not by a lot, and both of them are towards the better values to begin with. And P12 Redux from Noctua is again towards the top of the graphs. Next, taking into consideration 100% PWM, the very best here is the Noctua P14S. That's again a 140 millimeter fan. But of the ones we looked at specifically, here's the P12 from Arctic. It is towards the top of the graph. Here's the F12. And the P12 Redux is down here. So all three of them are towards the top, but definitely the P12 is really very good value proposition. But if you're more concerned about noise, I would go Noctua over Arctic. All right, where does this leave us? Well, let's go into the conclusion. The P12 and F12 are just not as good here at noise normalized, but they are still, particularly the P12, a pretty good fan. The main issue for the P12 here is that it gets noisy at higher RPMs, while the Noctua P12 stays relatively quiet. But if you're looking at them as case fans, they're both pretty good. Keep in mind, particularly for the P12, like I just said, it's noisy at higher RPMs, but both would be pretty good fans, especially as they are cheaper fans. So if you're on a budget, these would be an excellent choice. So there we have it, my roundup of less expensive PC fans. Which ones would I recommend? Again, just recap real quick. I would get this from my air cooler, assuming it didn't come with fans, or I needed to replace fans. And if I needed to get something for my case, do not get that Noctua. It is not good as a case fan. Either of these two would be an excellent choice. And the advantage of getting this P12 from Arctic is that if your CPU fan did fail, you could just slap this onto that radiator, onto that heatsink, and run it for that short period of time until your new fan comes in, because it does a much better job than the F12. So if you're looking at filling out a case and on a budget, $10 fan, get the Arctic P12. All right, that's it for this one. Thank you very much for watching. Again, please subscribe for more content and check out my Patreon page. Everything's linked in the video description down below, and have a great day.